Let's move on to a couple of more integration rules for different types of functions. In this example, we have the integral of something linear, ax plus b, to the power of something r. The integral of that is equal to 1 over a multiplied by r plus 1, and that's all multiplied by ax plus b to the power of r plus 1. We've got the constant of integration on the outside. Now this rule works all the time, except when r is equal to -1. Now it's pretty easy to see algebraically why r being -1 doesn't work. It's because this term here would be 0 and we can't divide by 0. So there's actually an alternative equation when r is equal to -1, which we'll move to in the next example. But first, let's just do this one, applying the regular rule to evaluate the integral of 1 over 2x plus 3 to the squared dx. Now, it's not exactly in the form that's above it. So what we're going to do is put it into that form. Now, how I'll do that is I'll bring the bracket to the numerator by flipping the sign of the power. So we should remember our index law. When you bring something to the top, you just change the sign. So in this case, it's going to be the power of -2. Now, our rule still works. It's still in the same form, except it's negative, but it doesn't really matter. We still just follow the same rule that it says here. So it'll be 1 over a, which is 2, r plus 1, which is -2 plus 1, and that's all multiplied by 2x plus 3 to the power of -2 plus 1. And then don't forget the plus c on the outside. Now let's just simplify all of this. We have 1 over 2 multiplied by -2 plus 1, which becomes -1. Then we've got 2x plus 3 to the power of -1 plus c. Now if we want to simplify this further, we've obviously got -1/2 on the outside, but because we got this to the power of -1, I could bring that back down to the bottom. So I could rewrite this as 1 over, or -1 over, 2 multiplied by 2x plus 3, and then plus c on the outside. Essentially, we brought that to the bottom. The power would be 1, so no need to write a power. And then I put the negative on the outside of the fraction, and I put the 2 at the bottom. Sweet. Okay. Now let's jump to the version of the rule where r is equal to -1. Obviously, I won't write it as the power of -1. I'll rewrite it in the simplified form where ax plus b is just at the bottom. Now the rule of the integral is 1 over a log base e of ax plus b and then plus c on the outside. Now I've got two brackets here. Well, it looks like two brackets. I've got these round brackets, which obviously encapsulates the log base e, and I've got these straight line brackets as well. Now what the straight line does, essentially it's called a modulus. Whenever you have something negative, it just turns it positive. Now the reason why that's necessary in this case is because we can't have a negative inside a log. We should recall that a log bracket can only contain things that are greater or equal to 0, or strictly greater than 0. So in this case, it just turns everything negative to positive, so that will get rid of any sort of errors that we have here. Now, let's evaluate this thing. We've got 2x plus 3 at the bottom, so it's very similar to last time, except obviously it's this unique formula. So to evaluate this, we go 1 over 2 log base e, and then we just do straight line 2x plus 3 plus c on the outside. Now just note that if you had to evaluate 2x plus 3 or whatever's inside this bracket, just if you get something negative, just make it positive, and that'll fix all your issues. Awesome. Now the last rule we'll talk about is an exponential rule. So the integral of e to the power of kx is equal to 1 over k e to the power of kx plus c. So you can see that it's a very simple form, similar to when you differentiate e to the power of kx. So let's evaluate the integral of 3e to the power of 6x dx. And we've got this extra piece of information here that says y of 1 is equal to 0. So we should recall that whenever we get an extra piece of information, most of the time it's going to help us find the c value, or the constant of integration. But first, let's just evaluate the rule, and then we'll just substitute that in later. So y is going to equal the integral of 3e to the power of 6x, but what I can do is take out the 3 to make my algebra a bit easier, like that. So this is going to equal 3 multiplied by the integral of e to the power of 6x. So using the rule, it's 1 over 6 e to the power of 6x, and then plus c on the outside. So we've got y is equal to 3 over 6, so that becomes 1/2 e to the power of 6x plus c. Now let's substitute in our information. So y of 1 is equal to 0. That's the same as 1, 0 as a coordinate, just to make it easier to write. So we get 0 is equal to 1/2 e to the power of 6 times 1, which is 6, plus c. So we end up getting c as negative 1/2 e to the power of 6, just moving that term to the other side. So therefore, our full rule for y is 1/2 e to the power of 6x minus 1/2 e to the power of 6. It's our final rule after evaluating the constant of integration using our extra piece of information.